So we're going to take off the drone. So first what I'm going to show is, I'm going to steer just towards the facade now. And as you can see, it comes to the set distance and it will automatically stop. No matter what you do, it's not going to let you fly into that. Yeah, exactly. So we're going to move sideways now, and you see it's automatically adjusting to the distance of the wall, especially with this protruding wall here. So now I'd like to show you two more things. So I'm going to reposition the Falcon a little bit. And now we're flying it sideways to the wall. And
now the real sense can't see the wall.
Yeah, exactly. So the real sense is pointing forward, and you see me pushing the stick sideways here, and it's still keeping me from colliding with the wall.
Okay, so how's it doing that?
So we remember the obstacles, and we keep track of everything that we had seen before.
So that's that intelligence at the edge. It's remembering where the obstacles were against the GPS location and saying, hey, I know there's something there even though I can't see it, and avoiding it.
Exactly.
Fantastic.
So lastly, you see there's a small flagpole over there on the right side of the facade. And this is usually very tricky to spot for a pilot. And we're going to adjust the Falcon a bit, and we try to just steer it right into it.
You're trying to hit that flagpole.
Yeah, exactly. So I'm steering forward, and you see it's automatically adjusting its flight path and keeps them at flight safe.
So it dropped down and avoided the whole thing.
Exactly.
Excellent.
All right. So we're done with our small inspection flight. We're returning to the landing position, and of course also on the way, obstacle avoidance is keeping our flight safe.
People always like a drone flight, no matter what. You can never fail with one of those.
Indeed.
You hear it, and off it goes. It'll now fly to its first waypoint, and you're going to see it now go through and do a full inspection of the surface. Still using the RealSense technology to make sure it stays a consistent distance away. Remember, there's no pilot here. Many people say this is the best way to have me fly, by the way. But the whole system is being done automatically. All the data is being collected. The cameras are already automatically going off at the set points. And all that data is being collected with its GPS location so that it all can be geotagged at the end of the flight. Everything is fully automated, all the way to the end of the flight. Okay, so we've shown you now that you can go offline, identify the flight you want to do, the system will help you. You talk about, you put in parameters like what altitude you want, what camera angles you want, how much photo overlap you want, all of the necessary things to really understand what's going on. You upload that then, we show you with the touch of a button, the system automatically downloads that to the Falcon 8 Plus, and off it flies. You've got RealSense on board, so you don't have to be that perfect about keeping the constant distance or worrying about something protruding, because the system will automatically see that and navigate around that.
So we collected a large number of images of our facade over here, and we're going to go ahead and load those into the system. Now this actually gives us a pre-visualization of where all the images were taken, their location and orientation to one another, and we can even see the camera angle of each of those. So we can verify that, hey, this is the right data set, we're not missing anything, before we go through the process of analyzing and wasting valuable time. So once we've done the check here, we can just select what options we want in terms of the ortho mosaic in a facade fashion, and click on continue. Now at this point, this is the real power of the system, is now we can add the analytical layers to the data. And in this case, we have options for plant counting, vegetation encroachment, or change detection. And that's actually what we're going to do here today, is we're going to do change detection. Because what we did is we actually ran 2 missions against that facade, and we made changes to it. So we want to see how the system actually detects those changes between those 2 missions. So we click on continue, and now we just have to select our previous flight and click on finish. And so at this point, it's going to start the process of uploading the data, doing that analytical process. Now, as you can imagine, as you run, like you said, more and more missions, and you collect lots of data, that's going to require a huge amount of computational power to process all that information, right? And so we're going to go ahead and skip ahead a little bit because we ran this analysis further, and it might take a couple hours to do that processing. So if we go ahead and go into the platform tool and actually start to review the data, now we've actually got both data sets in here. And we've got some basic tools that we can actually use to look at the 2 different sets of data. In the simplest form, we can just toggle between the 2 different sets. And visually, we can see there are some changes, differences there, so an operator might prefer to use this mode.
And if you're going to do just a visual inspection, that's probably what you would have done, right? Going back and forth, trying to understand changes and looking for those.
Exactly. For a typical operator, yeah, they can basically use a slider to change transparency between the 2. And again, this is all based on what does the operator really prefer to do with the imagery. Now we can also do the side-by-side. Now in this particular mode, what we want to do is we actually want to, like you said, let's see what the system has detected in terms of changes. So what we've done is we turned the change detection on here, and now we've actually got this side-by-side model. But we can go even one step better, is we can take a tour of all the changes that the system is detecting. And so now it's going to step us through each time. We get a closer look, and there, okay, we can see some of the stucco is actually sort of flaked off the brick area there. That might require maybe a little further inspection. Is there maybe some structural issues with that brick that caused that, or is that just normal? If we go to look at another spot here, we can see, wow, we're actually missing one of the pillars of the columns in that balcony. That could be a structural issue you want to look at, or you obviously don't want things like that falling on somebody's head. And next, we actually see here that we needed somebody to actually install a strap on this downspout, but it didn't look like they did a really good job, so we're going to have them redo that, obviously. And then finally here we have a flag post that is missing on this column balcony here. So these second examples are just a few centimeters in size, which could easily be missed on visual inspection. And really this tool is designed to make the most use of your human resources to actually focus on the problems that need to be looked at and not having to pour over every single image in your data set.
Right, so and I think you've done a great job of showing us how, the resolution and the amount of, the smallness of the change you can identify is quite good. And this will continue to get better and better as you collect more data and as the system gets smarter and smarter.
Tailing pile there. We can even do annotations, measurements. These are all common things that people do today with a lot of variety of different tools. Here we've actually got 3D. So now we can actually look at our model in 3D, full resolution wireframe, everything that's built into the system. So you've got all the tools that you would expect to use today, plus all of those analytical features. Now today, we actually did that analysis on the 2D facade, but we are also looking to be able to do that same sort of analytical capability on 3D models in the future.